So in AP Chem, there's a big emphasis on gravimetric analysis. Students need to know how to do the analysis of that. And they need to know how it works. If they're making a precipitate, right, they need to be able to filter out the precipitate from the filtrate, collect that, dry it, get the mass of it, et cetera. So that's something that the College Board actually encourages all AP classes to do at least once, preferably more than once, so that the students really know how to do that. Actually, in my first year classes, we'll also do a gravimetric analysis lab where they have to collect a precipitate and filter it out. So we do a lot of filtration. That's a big separation method for me. And in AP chemistry, chromatography is part of the curriculum, not in any great depth, but they do need to know the solvent front. This is the stationary phase. They're more attracted to one than the other. That's what really controls how far that particular substance travels, relating it to intermolecular forces not on a very sophisticated level, enough to be able to say, gee, I know the solvent is nonpolar and it moved along a long way, had a high RF value. That kind of analysis is something that can show up on the AP exam, and the students remember it best if they've done it. So I always like to do a chromatography lab with my AP students in person if I can. So we will often do paper chromatography, and some years when I have smaller classes, I might do a little bit of thin layer chromatography, because I have a sample of all the FD&C approved food dyes. So we can do okay, well, here's your mixture. Can you identify the unknown? Or here's the mixture. What solvent will get you optimal separation? So they have to measure RF values and calculate the ratios and all those kinds of things. It's something they are definitely expected to be able to do.